Good day, everyone, and thank you for joining today's webinar, Docker 101, Introduction to Docker and Containers. As a reminder, this session is being recorded, and a copy of the recording will be sent out a couple days after the webinar. We will take questions at the end of the session, so please type your questions in the Q&A window located in the lower right of your screen, and our speaker will address them for you at the end of the session. I would now like to introduce our speaker, Jenny Fong, Director of Product Marketing at Docker. Jenny, I now turn things over to you.
And welcome, everybody. Thank you for joining us on this first webinar of 2018. Happy New Year. Give me a second. I'm going to share my screen. So, as we mentioned, my name is Jenny Fong. I'm the Director of Product Marketing here at Docker. You can also follow me on Twitter at TechGalJenny. And what we want to do today is get everybody's new year started right with some learning about containers and Docker. So we'll go over the basics of what a container is, introduce Docker the company, and how companies are running Docker production. And at the end, we'll give you some guidance on how you can get started with your learning. So let's start with container overview. A container is an application packaging format. It allows you to run multiple applications sharing an operating system kernel while each of the apps are being isolated from each other. The Docker runtime is installed on an operating system. So that can be either Linux or Windows, and it helps to isolate the processes of the applications running on it. To help explain this concept a bit, though, let's make sure we all start with an idea most of you are familiar with, which is virtual machines. And we can look a little bit about how virtual machines and containers are different. So if you start with virtual machines, most of you know you install a hypervisor directly on top of a physical server, and then each VM, each of these columns, is a complete software stack with a separate operating system, separate packages and application stacks, separate copies of your code. Now what the hypervisor does is help share and schedule the physical compute, storage, and networking resources amongst all of these different virtual servers. So that's one of the reasons virtual machines came into popularity, was this ability to consolidate multiple virtual machines onto a single physical server. So one of the key things here is to also remember within a virtual machine, oftentimes when you're the VM administrator or you're the one managing the VM environment, you tend to look at a virtual machine as a black box. The hypervisor doesn't really care what's running inside of it, what the app is. And it's more of a physical construct of dividing the physical resources to those virtual machines. So now we contrast that to what a container is. So Docker is actually installed in an operating system. So not on bare metal, but it can run inside of an operating system. And it's an application layer construct. So to explain this a little bit more, let's talk about an application that has been containerized. So an application is built on a technology stack. In this example, we have Java, Tomcat, and Maven as different parts of the technology stack for this particular app. Now there's also custom code that leverages these software programs. Now, all of these file systems in a container environment are mounted as read-only files, and we actually call them layers. So how do we make changes in a container that's launched from an image? Well, we have a final layer, which is the writable layer of the app. So that final layer is the only thing that actually changes when the container is running. So what we have here is together the layers under, this makes up the container. These are all different layers within the app stack. And the things that are read-only, these are immutable read-only layers. What that means is when you have a Docker image, you don't need to write anything to disk. to spawn the process. And that makes instantiating or running a container super fast. And we're talking about like milliseconds fast. And we're going to do a demonstration in a minute to show you how that's possible. The Docker uses the same, if you have a second app, if you need to scale out this first application and you need another additional copy of container, this is really where things start to be interesting in terms of how containers work. So let's say we scale out this app and we can load balance between the two of them. Instead of having to instantiate all these read-only files again, most of these layers get shared. And so for everything that is shared, we only need one copy of them, not two, because these are all read-only files. Only that top writable layer needs to be separate for these two containers to run. So this is really where you start to see some of the benefits of container technology and how it runs so quickly, is that you don't have to reinstall an entire operating system or even Java on top of the operating system, because you're sharing the read-only layers between different containers. And you can continue that with an additional application. So if you were to add another application here, and now notice that while the Java and the Tomcat layers are the same, let's say this third app has a different version of Maven. Now Docker is intelligent enough to pick up that layer and is different from what's already been installed, and so they will install that as a new read-only file. But by the way, this also hints at how easy it is to patch and update containers. So if we say that we wanted to patch this last container to use a more recent version of Maven, we would just change what's called the Docker file that tells the system what layers to use. So it's a single line in your Docker file that says, instead of using Maven 3.3.9, we want to use 3.5.0, and then I would just re-instantiate the container with the updated patch. So this is starting to really highlight what some of the core differences between virtual machines and containers are. But we can carry this out even further. And we can take this out if you have a single Linux operating system, you can run different flavors of Linux on top of that because they're using a common Linux kernel. But you might have different sets of layers needed for different types of apps. But again, anything that is shared is shared will reduce the actual resource needs on your system. But this isn't limited to Linux. We've been working with Microsoft in a partnership that started in 2015 so that you can run Windows containers as well. So Docker gets installed on a Windows server, and you have the same benefits of this sharing of layer capabilities there as well. So the other point of difference between virtual machines and containers is if you think about, again, Docker being more of an application layer construct versus a hardware construct, the containers need less storage. They need less RAM because we have fewer copies of everything and because we don't really need that separate VM for each container. And this really starts to help with data center efficiencies, and we're going to explore that a little bit more. What I showed you, though, was Docker running on Linux and Docker running on Windows. Now, what that means is that can be on bare metal, or it can also be running on a hypervisor. So we can actually do all of this running inside a virtual machine. So you have your hypervisor, you have a Linux VM, a Windows VM, you install Docker on top of those, and then you run multiple containers inside that Linux VM or that Windows VM. And again, so we see a lot of significant consolidation benefits when customers use these together, up to the tune of 25% and sometimes even greater than that, depending on how customers have deployed their virtual machine. So just to reiterate, you can run Docker on bare metal or inside VMs. They operate at different layers or at different levels of the application stack. So it's really just a preference decision and how your organization wants to manage containers. Some people prefer using them inside virtual machines because they have tooling around the virtual machine, you know, in terms of governance and placement and things like that. Others like running them in bare metal because of the lesser overhead. It's really just a preference of what customers want to accomplish. So having kind of walked through some of the basics of containers, let's go to a quick demo. So what I'm going to show you in this demo is based on running Docker for Mac. So give me a second, I'll just clear screen. So this is installed in my laptop, and it's something that you can freely download for yourself today. What I'm running is the edge release, and there's an edge release and a stable release. You can choose which one you want to do. So with that installed, I just have to open the terminal, and let me kind of increase the size. And what you can start doing is executing the Docker commands. Oops, sorry. So let's see the version I have. The reason I have the edge release, and I'll talk about this a little more later, is we have some new developments around our support for Kubernetes, which is a orchestration standard for containers. And this particular version of Docker for Mac supports both Swarm and Kubernetes. So let me show you right now, my system is empty. So I have no running containers in my system right now, but I do have some images that I've already downloaded. So I have an Alpine image, Nginx image, Ubuntu image, a Hello World image. A lot of these images are there for supporting the Kubernetes piece, but these are all, when we talked about those shared layers, right? Those shared layers form images that are read-only files. These are the read-only files that I already have installed in my system. Now, what if I want to pull a new image file? Well, that's an easy instruction. I just say docker pull. Let's say I want to build a new app using WordPress. That simple command will look for WordPress in my library. The fact that I don't have WordPress in my library means it will automatically go, and let me open this for you, to the Docker store, or what used to be known as Docker Hub. And what it's doing is it's looking for an image of WordPress, and this is something that has already been built, and it's in a library or a repository for you to download. So you can do that with a lot of different types of applications. You can do MySQL, we actually have support for Oracle workloads. So a lot of different images are already available in the hub or Docker store that are provided by both the community as well as software vendors. But what I just did was I pulled a new image into my system. So if I do Docker image ls again, you should now see that we have WordPress in here as well. So this isn't anything live though. This is just an image. This is just read-only files. There's nothing happening here. To make it actually a container, we're going to have to instantiate the actual container runtime. And for that, let me first prove to you that I have nothing running on localhost right now. I can refresh that. There's nothing there, right? So what I'm actually going to do is show you just how fast it is to instantiate a container, and hopefully you'll start to see why this is different from a virtual machine. So I'm going to do Docker run, a couple of commands here that I can explain, but basically I'm doing some port mapping of my laptop, and so that when I access port 80 on the local host, it will talk to port 80 in the system. I'm going to give this runtime a name. I'm going to call it Docker 101 demo, and I'm going to base this on Nginx, okay? So I'm going to ask you to watch closely now. I'm going to press return, and then you'll see how quickly this takes to instantiate a brand new Nginx. And it's done. And so if I press refresh now, there you go. So that's what we talk about, millisecond speed. So imagine if you're building a server from scratch. You would have to, upload an operating system, upload Nginx. You'd to do all these steps, which take a long time. You could automate that with scripts, but the installation process is still very long. What we did is we took an image file that was available through Docker Store, and I'll show you that again. So I just looked for Nginx. There it is. It tells you how to pull it. I just have to pull this image down. The same way I did WordPress, as you saw that the file started downloading. It took maybe, 25 seconds to get that whole thing downloaded from WordPress. And then running it was just a single command, and that's what we get. So that's the quick demo, just so that you guys can get a sense of what containers are. And hopefully what you saw out of that demo is a couple of things. Hopefully you saw the speed. Speed is really key here. And this is a huge improvement for software developers because that means you can deploy different tech stacks for in just milliseconds. If you think about it, this is also great for testing because you don't need to build machines from scratch for testing. You can really just build a Docker file with a certain stack and deploy that. And you can start to see that this is also very portable. So if you think about what I just did, which is pull an image from a repository to my local machine and then run that local machine, local container, my teammate in, let's say my teammate in Europe could do the same exact thing. They could take the same image file, download it to their machine, and then run that same container. So you have this consistent container running on different machines, all running Docker, and it will deploy exactly the same way for my teammate as well as myself. This really starts to solve a lot of the software development lifecycle problems around what we call the quote-unquote works on my machine problem, right? Because the app is getting built exactly the same way with the exact same versions of Java and Maven and everything else that makes up the application. And finally, we saw some of the efficiency improvements that we can get out of the shared layer concept. So that is Docker, that's containers. Now let's jump a little bit to Docker, the company. Docker is the company that's driving the container movement and maker of a container platform that addresses multiple applications across the hybrid cloud. And the journey from what Docker started at to where we are today has progressed pretty dramatically. So if we think about the original, Docker was founded in 2013 at basically shared out at PyCon. Our founder, Solomon Hykes, he took this concept of Linux containers that's existed for many, many years. But what he did is he made it usable. So he made it so that containers can share and be isolated, but at the same time share networking and storage and other resources. So he basically created this concept of Docker containers, and the growth option amongst software developers was incredible. It exploded, and we hit 1 billion downloads of Docker images in November 2015, so roughly 2 years after this was launched. But then we hit 2 billion only 3 months later, and then hit 4 billion 4 months later. So you can see that the growth of containers was very rapid amongst especially the Linux developer community, and we were solving some clear issues for developers. Now, what happens over time is these containers that were being used by developers on their local machines, they want to start pushing some of these apps into production, and the number of these apps start to grow. Now, what happens then is a lot of times developers are going to want IT or operations teams to take care of them and to manage them and to secure them. So over time, what Docker has done as a company is we've on creating solutions to allow enterprise organizations to run containers at scale securely. So that's what we're going to talk about for the rest of this talk, which is the movement from a free developer open source tool to an enterprise platform solution. And a key part
Jenny,
of that.
I'm going to jump in real quick. I'm getting a couple feedback from some of the folks that every so often it's getting a little garbled or kind of going in and out. I don't know if there's a different way you can adjust the mic on your computer. Sounds pretty good to me, but every so often there does seem to be some missed words.
Okay. Let me do this. I will go ahead and dial in from phone. I apologize for everybody. Give me a second to do that.
Yeah, now it's kind of fading out more, so thank you. Everyone, if you just hold with us, we're going to have our speaker call in and try and fix a little bit of the audio problem that some folks have been experiencing.
Sorry for everybody who's waiting.
Hi there. Can you guys all hear me now?
That sounds very clear, Jenny.
Okay, great. Sorry about that, guys. Thanks for letting me know. As I was saying, so now we have a single platform for both developers and IT. So we have Docker Community Edition, which is free for download for anybody on their local machines. And then we have something called Docker Enterprise Edition, and that's really targeted at organizations who need to manage and secure and run Docker in production. So Enterprise Edition is a subscription-based solution, and we're going to talk a little bit about what that solution does by thinking about what you need to happen when you're running Docker in production. So what we already saw is in the demonstration is a developer's point of view. So developers typically use Docker for Mac or Docker for Windows, and that turns their laptop into a local Docker host. Now this gives the developer the ability to run local containers, to do their coding, to do their testing, to do app development in their own systems. Now what they'll do is they'll be working on images. So they'll be working on getting the app to a final image that is what they want to push to production. And we talked about the image file and the layers and all of that. But developers will want to store those images somewhere in repository. Think of the image as like the instruction blueprint for the actual running container. So developers can create their own images from scratch, or they can leverage pre-built and certified images from the Docker store, which is similar to what you saw me do. I can pull a base image from Docker store, I can make edits to it and add my own code to it, and then save it as a new image. Now developers push and pull images from an image registry, and that's a library where images are stored and managed. Now the image registry can be shared or private, and it can be hosted locally or in a cloud service. Now Docker Trusted Registry is an enterprise-grade solution that is included in both our Enterprise Edition Standard and Advanced editions. And this provides the ability for customer to set up a private registry in their chosen environment and integrate it with their, corporate LDAP or Active Directory and set rules of access to that registry. So most people starting out may upload images to the cloud, which is Docker Hub or Docker Store. But again, if you're running things in production, you're not going to just put your code out there. So the idea of a secure image registry through Docker Trusted Registry is an important part of an enterprise-based solution. Now when we go to run those apps, this is where there's typically this handoff to the IT ops team, where the ops team needs to make the decision on where these applications should run. What cluster should it run on? Should it be on-prem or in the cloud? And the ops team wants to choose the best location, which can be a mix of pre-prod or prod environments. And these environments can be a single Docker host, just like our laptop is a single Docker host. But more often, it's going to be a cluster of Docker hosts. And in order to manage these clusters and where the containers run on them, there's something called orchestration that we'll go into a little bit more. But in general, the operations team is going to want to have some sort of control plane to manage all of this. So they're going to want to be able to see where containers are running, as well as be able to make decisions on addressing any problems that arise. So if we put all these pieces together, what you have is a secure software supply chain for the enterprise. We call this the software supply chain because it's very much like thinking about, you know, let's say you order something online. There is a supply chain from getting that item from the warehouse to your local distribution point to your door. And similarly, in software development, there's a supply chain for taking an application from a developer's laptop and getting it securely to production. And so with Docker Enterprise Edition, we provide the secure Docker trusted registry as well as the universal control plane to give you that single platform for managing the applications. So Docker Enterprise Edition is a container platform solution. It helps you control who has access to what, where things run, but one of the main benefits of our solution is that it supports more applications than all other platforms, in the sense that we can support traditional apps and microservices apps. We can support Windows-based Linux, IBM mainframe, so both IBM Z and IBM Power. We can support big data. And what we're seeing more and more are customers leveraging container technologies for their next generation apps. So things like moving to microservices, things like edge computing, IoT and serverless computing. So really, Docker Enterprise Edition is really the platform for applications supporting both what you have today and what you need in the future. So with that, let me jump into another demo so you can understand what Enterprise Edition looks like. And I know there's a bunch of questions coming in. I will get to those at the end. Let me jump to. So this is a look at Docker Enterprise Edition, and then let me jump back out. This is, I will point you guys to this environment at the end of the webinar, but it is our hosted trial environment. You can sign up and get access to a hosted environment so you don't have to download and install it yourself. What it is basically, if you're familiar with the VMware terminology, it's sort of like vCenter for your containers. It's the centralized dashboard and management platform for all your different containers. So on the dashboard, you can see what CPU memory is being used, the number of containers you have, images, everything like that. We talked about the trusted registry solution as well. So let me start there. So remember, this is where you can check in and check out different images. So what you can do is set up different organizations. If you have developers versus your QA team versus your test team, you can set them up with different permissions. They can set up different folders or repositories for those images. Now, within a repository, I'm going to go here. You can see what images are in here. From this one that we're looking at has been gone through something we call security scanning. So security scanning is a feature of our Enterprise Edition Advanced. What it does is for every image that you check in, it will look at your Docker file. This is basically the Docker file broken out. A Docker file, like I said, is a set of different image layers that you define, and then each of these layers are getting checked against the NIST known vulnerability list. And so you can see that what it's found is, hey, you added BusyBox 1.27.2 into your Docker file. We know that there are 3 major vulnerabilities. The 3 major vulnerabilities are listed here with a link to their CVE files. And so this is a great asset for organizations who want to make sure that before they push anything to production, that this particular image is clean. It has the latest patches, it's secure, or at least it has vulnerabilities that have been addressed. So that's where the Docker Trusted Registry. Now, let's say we have an image that we're happy with, and now we want to create the runtime. What's great about this environment is the instructions are all there. I'm going to do that and use the code that is here to cheat, because it takes a long time to type, especially when you're doing it live. So I am just going to copy and paste that here. We'll call this Tomcat and services. And this is what's called a YAML file, which is defining the container service, and we're going to create that. So as we create that in the demo environment, when it's done, and I'll go back to, and we can see it's done, the home page here. And now you're going to see that just a few seconds ago, we added this new Tomcat container. Again, speed is key, but you can also use this universal control plane to help debug any issues. So we can see what containers, what networks have been defined, what containers are attached to which networks. We can look at what volumes there are, things like that. So this is your management interface to your container deployments. All right, so what did we just see? So what we just saw is Docker Enterprise Edition. Specifically, some of the features I highlighted, like security scanning, are in our advanced edition. This is a kind of a visual diagram of what is included in Enterprise Edition. So we have the actual container runtime, or Docker engine. We have the interfaces and plugins to allow you to leverage your preferred storage vendor, whether that's NetApp or whatever it is. It allows you to plug in different networking solutions. And then the key part that we highlighted was a lot of the different lifecycle management components around policies and Active Directory integration, security scanning. There's also something called security signing, or image signing, that we won't have time to cover today, but you may want to read up on. So in this discussion, you'll notice that one of these boxes is called orchestration. So orchestration, if you want to think about it, is the literal part of this tool that says this container should run X number of copies on this particular node. So the words or the names that you might have heard of in the container space is Kubernetes. And I wanted to touch briefly on this because recently we announced our integration of Kubernetes to Docker. So there's really sort of two parts to orchestration. There's cluster management and the scheduling of apps. Now when it comes to Kubernetes, this is a standard that was created originally by the Google team, which is now open source. There's been, rapid adoption of the Kubernetes orchestration framework. And so as part of this next release of Docker Enterprise Edition, customers are going to be able to use either the Swarm orchestration that's built into EE already, or Kubernetes, and you can choose to do so in the same cluster. So again, we talked a little bit about, supporting a broad set of applications, a broad set of platforms. Now we're also supporting a broad set of orchestration tools. The benefit of having both Swarm and Kubernetes available in a single cluster means that for the operations team, they don't have to separate out different workloads for different types of orchestration. You can run them all and manage them all in one place. And in addition, some of those security features we talked about, like image scanning, are supported with our for Kubernetes workloads. So again, providing that additional layer of security and management for your container environment. I do want to jump now into a couple of real customer stories around Docker so that you can start to think of why would a customer or why would your organization need Docker Enterprise Edition. The key is kind of going back to the main benefits of containers, but also some of the things that we know we bring to customers with EE. It really is about portability, agility, and security. So portability, a lot of customers look at containerizing applications as a way to make them cloud ready. So once a application has been repackaged into the container format, we know that that can run on any public cloud. It can run on-prem or in a hosted location. It's very portable in that format, and it's a standardized format that runs the same everywhere. The second is agility. So we talked about that with the speed. So we can move a app from dev to test to QA to pre-prod to production very quickly, partly because of the lack of that works on my machine problem, right? We don't have to worry that the pre-prod environment is different from the test environment because one person had attached one layer of Java there and not in another environment. Like, not all that goes away because it's defined within the image file. This helps to really drive agility. It also helps new hires who are new to in a company's processes. They can pick up on the code really quickly because the Docker file spells it out. So there's not this huge, manual that tells them how to build the stack. They just download that image and they have the stack. And finally, security, and there's a lot of security benefits. We recently ran a security webinar that was back in November, and I just recommend everybody to take a look at that, and we'll probably run that again later this year. But things in containers have a smaller footprint of things are easier to patch. People can isolate issues faster, redeploy faster. And so there's a lot of these general benefits for our customers, but the really fascinating one, or the one that we've seen over and over again, is how Docker actually helps companies save money and save up to 50%. And now that's a big number, and a lot of people doubt it. So here are a couple of specific stories to help you see where that's coming from. So one of our big customers who's participated in DockerCon, they've been part of our keynote, is MetLife. MetLife, the insurance company. They have been around over 100 years. They have multiple lines of insurance, from life insurance to dental insurance to all sorts of things. One of these bigger companies who's been around for so long, they have a lot of different systems of record. They have 400 systems of record. They have a ton of mainframe in place. There are policies that require them to keep data on hand until the last policy holder expires. And so there's just a lot of existing systems that are there, but they also know that there's demand on their agents and their customers and their partners for these new mobile experiences, these new sort of Web 2.0 experiences, even if the data itself is on these old systems of record. So they're looking for ways to innovate inside of MetLife, but they need to also keep the lights on. So we often hear this 80-20 number, right? 80% of your budget is in keeping your existing apps running, where only 20% is getting dedicated to new innovation. And so that's the problem that they were faced with. They have all this existing stuff, and it's taking a long time to manage and do everything with, but at the same time, they have these demands for new innovation. So what MetLife did is they worked with us and our partner Microsoft through this Modernizing Traditional Apps program, which I'll talk about in a minute. And what they were able to see with that program is they took a single technology stack in their environment. So they looked at, I'm just going to make this up, but think of it as like they've looked at a Java app that used a common set of technology that was used across the board. With the single app, once it was containerized, they knew that they could get improved efficiencies out of that application. And then they looked at their entire application portfolio and found that this technology stack was used in almost 600 different applications. So the same app stack was used across a lot of different apps. And if they multiply the efficiency savings that they get from that single application across all these different applications, they see that they can get up to 60% cost of ownership savings. Now, when you look at these 600 apps, that only represents 10% of their application portfolio. So if they apply the same process of containerizing an app and then moving them into Docker, they recognize a ability to really get huge savings out of this project, which then can help them also do some of the new things that they want to do. So things like moving to cloud, doing the consolidation. And once we have these savings, that means more time is spent on these new projects rather than the old traditional apps. So another story that I did want to share is Finnish Railways. They were a speaker at our DocuCon in Europe in October. So Finnish Rail, you know, it's a transportation company. They support 82 million passenger train rides and transport over 36 million tons of goods in Finland. And because they're a government-run entity, they didn't have an in-house software development team. They typically leverage different vendors and system integrators to help them build their application portfolio needs. One of those partners is Accenture. So similar to other companies, they still had a lot of old mainframe-based apps that they really wanted to update. So what they started with in their journey is actually re-architecting their old reservation system, which is based on mainframe, and building it from scratch with microservices. So microservices being, hopefully most people understand what's attractive about that, but they worked with Accenture to rebuild the application in microservices, and then they've deployed it on Docker EE. But one of the really interesting factors with that journey is, in the meantime, they did see the value of moving traditional apps to their Docker environment, and they started to migrate existing apps as well. So they looked at Docker EE as a single platform for refactoring their applications as well as containerizing existing applications as they are. So the solution for them to get a common platform out there, all the different vendors can use the same processes, there's the same handoff between developers and operations teams, and they can bring everybody into this consistent format. They also did see average cost savings of 50%, and that's across all those different projects, and with better visibility into their apps as well. The last story I want to talk about is one of those organizations that's using Docker EE for the next generation of technology. So GSK, or GlaxoSmithKline, they also spoke at DockerCon in Europe, and they're using Docker EE to drive their big data research. So they're a cloud area shop using big data to help get results faster with their pharmaceutical solutions and drug discovery. So they're leveraging Docker EE as a way to quickly deploy lab environments for their data scientists. If you think about data science as a kind of a new and emerging field, there's always new technologies and stacks out there. So they wanted a way to quickly adapt to their scientists' needs, so that instead of the traditional, 2 to 4 months to stand up a solution, they can now do this securely and safely in minutes. So Docker Enterprise Edition is getting adopted across a broad range of different companies and different industries. Anybody who has traditional apps can benefit from this, and anybody who is building new apps can benefit from this. And so that's where we see this broad adoption across the board. So let's talk about how you can get started with Docker, or how your organization can get started with Docker, and then I'll answer questions, and I know there are several. So what we do see as a successful pattern for organizations adopting container technology is to really just, start with one. That's kind of what MetLife did here, where they chose one application that was representative of their portfolio. They learned how to containerize that application, and now they can apply that practice across 600 different applications. Now that they have that system set up and the processes laid out, this allows them to then move on to the second stack of applications. But that could also mean that it gives you the possibility to concentrate on integrating modern methodologies. So if you're working through your CI/CD workflows, you're trying to implement microservices, whatever they may be, the ongoing innovation that this really enables. There's a great quote from MetLife. They called it a self-funding exercise. So basically the savings that they can get from consolidation and efficiency improvements just by containerizing those first set of apps helps to fund their new innovation workloads and new innovation projects. So to help you on that journey, we have a program that I alluded to earlier. It's called our Modernize Traditional Apps program. This is something that we deliver in conjunction with partners like Microsoft, Avanade, HP, Cisco, and there's one more is IBM. So in conjunction with them, we will work with you for 30 days to teach you the basics about containers, getting Docker EE set up, getting your first set of applications Dockerized and running. And that will give you the tools to then apply that same concept across all of your different applications in your environment. Now, if you are just on your personal journey here learning more about containers, we do have a bunch of different ways for you to get started. Honestly, the easiest thing to do is to download the free Docker for Mac and Docker for Windows. That was the first demo that I went through. That is something you can get into your installed today. You can start working with it, start playing with it, seeing it for yourself. We have a bunch of guided tutorials in documentation, or you can also access something called our Play with Docker environment through training.docker.com. So the Play with Docker environment is a hosted version of Docker, so you don't even have to install anything. It just runs in your browser, and there are a bunch of self-paced exercises there, depending on if you're coming from sort of an IT background or developer background. There's different exercises for you to try. We have a bunch of videos on our Docker channel on YouTube you can access. Now, if you're looking at Docker EE and the management platform, you can also go to that hosted trial environment I talked about, which is accessible from docker.com/trial. You just sign up, and within minutes, you'll have your own EE environment for you to play with. It is timed out after a few hours, but you can refresh it as needed. And then the last couple things for learning is, do keep looking for upcoming webinars. We add them on a monthly basis, so there's always new ones being added. We also have a specific site for anybody who's coming from that IT background that wants to do more learning on Docker. You go to docker.com/ITpro. You can sign up for a newsletter there or access the different content. And with that, I finish my part. So now let me stop sharing my screen and start answering questions. And just as a reminder, hopefully everybody's been using the Q&A window. Okay.
I think the first one comes in around 12:08.
Okay.
Jenny from, let's see if you see it there. It's a question about Docker container application. It says, yes. Is it possible to use the Docker container application with connection to standalone Oracle DB, or the DB must also be part of the container?
I see that. So it's both. You can actually containerize Oracle DB. We have in our Docker store, and I'm not sharing my screen anymore, so let me do that. In our Docker store, you can see that we have, let me go back to the front page so you can see this. When we go to containers, there's a button here called Docker Certified, and you'll see that these are certified containers provided by different providers, and we have Oracle containers, including Oracle DB, but I have to filter it, sorry. But yes, Oracle DB is a container that you can have. Now, once something's in a container, it's very much like a virtual machine in how you do networking connections. So basically, you can connect a container through layer 2 routing to anything else, so to a physical machine, to a virtual machine, to another container. So it's really just a software-defined networking routing between one thing in and another. The next question, OpenSUSE. So we do have a support list. Let me go to, and I keep forgetting, I keep stopping sharing. If you go to documentations, you'll see in there a supported operating system list here. And so you can actually look at what can run, but we do run with SUSE and SLES and Red Hat and Oracle. So it's in the documentation. You can just look for that full list. Let's see what else. There was an image on slide 11 that showed a guest OS within a Docker container. There was. Supported through the hypervisor. I just want to make sure I have the right slide. Oh, sorry. So that was actually inside a virtual machine. So that's what we were saying. You can run Docker directly on bare metal running on the host operating system, or you can have this Docker running inside of a virtual machine on top of the guest OS. So that's what this diagram was showing. So the question, I think I addressed there. And then, so there was a kind of a question about which resources should we look at for containerized OSs. This is where in the Docker store, in the hub, and even just through the community, basically, you know, we have Alpine, we have Red Hat, we have all these different flavors of operating systems. You can just choose the image of what you prefer. Does the Ubuntu image contain the entire Ubuntu OS as read-only, or is it lighter than that? It is the entire Ubuntu image, and so that can be a heftier image file. And again, let me kind of open this so you can see. You'll see that my Alpine image is 4 megs. My Ubuntu image is 111 megs. So that's kind of the difference. So this is the full Ubuntu stack. What you see in adoption patterns is as organizations get more advanced with containers, they really do care about layer sizes and stack sizes and image sizes. So you'll see a lot of different things that people do to reduce the size of their image. But let's say, remember, one of the easiest ways to get started with Docker is just to containerize an existing app. If an existing app is running on Ubuntu, then you're going to need the full Ubuntu. So that's what the difference is. Is there a list of software supported with Docker on your site? So that would be a mix of Docker Store. So again, you can see not just the platforms you can run on, but we have certified containers, certified plugins, all in the Docker Store. There's a question on third-party licenses. So I'm guessing it's like software licenses like Nginx or sorry, like Oracle licenses. Yeah, that's something you would own the responsibility for. We do have a lot of good partnerships in place. A lot of them are working with us, but that is something that you would have to work with your particular vendor on. And yes, containers can run on bare metal servers on top of the host operating system. So you can install Alpine on a bare metal and put Docker on top of that, but it does require an OS kernel. Okay, if all containers are in the same physical host or VM, the apps running in these containers are accessible via the port or the same IP address? No, so that's again, it's very similar to virtual machine networking at that stage. Within the VM, you can set up a subnet with different ports and do port mapping, and we have built-in routing for that. And so there is a networking webinar that we did in October. You can refer to that one, and I'm sure we'll run that one again as well. Licensing and pricing for Docker, you can go to docker.com/licensing /pricing, and you can see the different editions that we have. They are sold, the enterprise editions are sold on an annual basis. We have basic, standard, and advanced. So after deployment to production, how does Docker handle upgrading of apps? And what if the common shared components need upgrades? So each container still is based on an image file, right? So when I do a Docker run demo Nginx, it is pulling from the Nginx image file. It's just being given a new name for that particular container. So if I wanted to upgrade the container, I am upgrading the image file. And so the difference, I would say, is from traditional patching and upgrading versus what you do in containers. In traditional patching and upgrading, what you do is you typically install a patch to a running virtual machine. Maybe you have to power cycle depending on how it operates, but you're installing the app, the patch. Whereas in containers, typically what people do is they replace the container. Because containers spin up so quickly, I can just kill the container, update my image file with the new updated number, run a new container based on that updated image file. And that's typically what people will do because I can do that in seconds. And of course, you can also script that for automation. Customers that do like blue-green deployments, rolling upgrades and things like that. The other benefit in containers is rollback is very simple because that's just going to the previous version of an image. And so, again, these are things that really do optimize the operation time and pain and suffering that upgrading can do. Can we create our own Docker image? Yes. I'm not going to show that. That's more of a developer function, and it depends on what developer IDE you have and things like that, but you can. So within the CLI, what you could do is you can pull an image file, like let's say I pull Ubuntu. I could add my own packages on top of that, and you can do that in a Vim or whatever, but I'm not going to go through that. You can do that through Play with Docker, that training.docker.com. There's a tutorial to guide you through that.
And Jenny, we probably have time for one more question, and there's a lot more rolling in. So I don't know if you'd be willing to maybe answer some in a blog. We will save all these questions and maybe address them in other means. But if you want to look through and pull out one more to answer, we are at the top of the hour.
Thank you. Okay, so there's so many. How do I choose? Okay, there's some questions about Kubernetes I do want to talk about since that is something we are focused on. So the announcement was made in October. We started our private beta in December, and we're just about to launch the public beta. So if you're interested in checking out and learning Kubernetes in a very simple format for EE, you can sign up for beta at beta.docker.com. And you'll need a Docker ID for that, but then it's a public beta that we're going to be launching very shortly. If you want to try it locally, you can do what I did, which is you can download the latest release of Docker for Mac. So the Edge release for Docker for Mac, let me go there. As I mentioned, there is both a stable channel and the Edge channel. You're going to want to download the Edge channel because this is a new release. And once you have that, you're going to go into your preferences and you are going to enable Kubernetes. And so that's all you're going to need to do. And just to prove that we have Kubernetes installed in the system, let me just do one quick kube command. Oh, I'm not sure why that didn't work. Okay, but anyways, it's basically installed as part of this release, and you will have access to it. And that is all I have time for. What I will do is take all of these questions, and we will address them in our blog. Give me like about a week to go through that, and we will make sure we get all these answered for you there. Otherwise, this is being recorded, and it will be sent out following the conclusion of this webinar.
Great. Thank you so much, Jenny. Thank you, everyone, for joining. As Jenny mentioned, this concludes our webinar, and we are recording this session, and we will send out a copy of the recording with the slides to you all in a few days. So thank you again so much for joining us, and have a great day.